Okay, guys, let's move on and prepare for paper 2 quickly. And I'm sure everyone's biggest fear is Euclidean and trigonometry. That's always the biggest fear. So, in order to make the fear, let's remove the fear. See, I don't have any questions. Okay, we're just going to go randomly today and just pick anything because also your paper will be random. So we're just going to go randomly. Just going to go randomly, and let's just play around a few Trig's and Euclidean questions. Just to make sure that we are on board. I don't even know where to go. Okay, let's see something. Let's go to 2022. Okay, if you say 22, let's start from May June. I always like the May June papers. Let's see what the May June had in stock for us. All right, check this out. Beautiful. Okay, but let's start from. All right, let's start from here. First 18 marks. Do you think we can get this 18? But I'm sure this first, before we go to general solution, I'm sure we can get this ones. Come quickly. This 5 marks, I don't even have to do anything. You guys are capable. You want to try that for me quickly? 5 marks. Everybody working. Let's see if we give ourselves 5 minutes. The diagram is already drawn. You're not even thinking here. Come, 5 minutes. Let's walk through together. Guys, I'm sure we are done with this question. Can I see a thumbs up? I gave 5 minutes because I know some of us are just logging in, and I wanted to just catch the question so that you can also have a chance. But right now, I'm sure we are all done. Give me a thumbs up quickly or thumbs down. We only have about 41 seconds left. And that's it. Now, quickly, guys, before I even start anything, can I just take a moment to do something very, very important? 5 minutes or less than, please. If you are struggling with trigonometry, especially on question 5, what are the important things? There's just about 5 things that I need you to see quickly to know. Sine theta is y over x. Cos theta is x over r. I am like this because of my x. That's what I like saying. All right. And then your tan theta is y over x. Don't forget this. Never, ever forget this. Second one, sorry, y over r. Y over r. And the second one is r squared equals to what? X squared plus y squared, bearing in mind that r is always positive, greater than 0. Those are the few things that must always be at the back of your mind. And you then remember that whenever you draw, we call it a trig bow tie. Don't forget that. It's a bow tie, which represents everything you need in each quadrant. There we go. And this would be your theta in every quadrant. R here, Y here, X here, negative X here. Let me put it outside there. What do you have here? Negative Y, positive Y. R is always what? Positive. Now, this is basic. If you remember this, the rest is to reduce. So this is very, very basic. You know your sine, you know your cos, and you know your tan. Obviously, we're in grade 12. We should know that here, our angles are what? Acute angles less than what? 90. There, we add another 90 to it, and we move to what? 180. Here, 180 degrees, and we move to 270 degrees. And then 270 degrees, we move to what? 360 degrees. And we know that all students take coffee. And we always move anti-clockwise, where this is your starting point. Lovely. Once I'm able to remember this, I am going to be done with my question 5. Everything that question 5 will test on is right on this page. And I'm sure we still know how to reduce. I taught you how to reduce. You can even use your calculator to do the reduction. So that is a quick crash course on how to deal with question 5. You remember this and you just apply. Guys, I want us to prepare so well for paper 2. Okay, can we answer the questions now? Can we answer? You can just screenshot and leave it on your phone, send it to yourself. Okay, we're good. Now look at this question. The first thing I'm going to look at in the diagram, okay, we've all read. Look, are you aware that I am going to just complete this diagram if I were you. Now, what do I have? P. Already, do you notice that I have my X and my Y? What is missing? And that is your R. If you look at that triangle I drew for you. And that, oh, by the way, guys, this diagram, let me do something here. It's going to be an error. It's all 90 what? Degrees. They're all right angle triangles. That's very important. Okay, now, since this is a right angle triangle, check how sweet I can quickly get this. We can find R by using the theorem of what? Pythagoras. Done. So what do you have? I'll do it on this page. R squared equals to what? X squared. I'll tell you where the challenge might be when you substitute. People do this, and that's where the problem is. This will give you a wrong answer. Please, let's learn the simple mistakes that, and how to avoid them. That would give you a wrong answer. How do I fix it? Can somebody please tell me how to fix this? Ian doesn't see what's wrong with this one. Can somebody please tell me what's wrong? Because this is a common error. Yes. Jalo?
You have to put the -7 in a bracket.
Please put the Put the -7 in bracket. Without that, you are going to gallantly get a wrong answer. Those are basic things that I need us to know. So what do we have? It's going to be the square root of -7 squared. Even when you type, please type it the exact way that you have written it down. That's why writing is important. Plus 4 squared. And that gives you what? Root 65. Please leave it as roots. I've tried to avoid decimals. I'm done there. 2 marks. 2 marks. Now I know my X. I like to write it out. What is my X? -7. What is my Y? 4. And what is my R? Root of 65. Now, the value of tan theta. Beautiful. What am I looking for? Tan theta. What is tan theta again? It is the Y value over the X value. What is your Y value? 4 over what? -7. And I'm done there. And the second one, B. What is cos theta? This is reduction. Do we all still remember how to reduce? Head nod and head shake just works for you. 180, we don't change the trig ratio. And then you come to your calculator. We're going to repeat that now quickly. I just put 1 there to see, is it a positive or a negative? I'm getting a negative answer. Just put 1 everywhere you see theta. My answer, therefore, is negative cos theta. What is cos again? Cos theta? X over what? R. So it's X. Okay, just but we can follow through. What is my X? Negative what? 7. What is my R? Root 65. Now, negative times negative would give you what? A positive. 7 over root 65. And if you want to rationalize, I'm sure you know how to rationalize. Multiply top and bottom by root 65. It's going to be 7 root 65 over. But then you can use your calculator. But don't write the decimal, please. Because the examiner says without the use of a calculator. So once you start writing decimal, you are just exposing yourself. Are we all on the same page there? Thank you, Noran. We put brackets. It's a common error, and somebody would have gotten it wrong in an exam. So please, let's learn. The idea of going through this is to quickly relearn some of the things that we need to learn. Oh, you know that I love this one, general solution. I love it. 7 marks. Okay, general solution. Guys, please, one of the greatest rule that I always tell you on general solution, never ever divide. Please, never divide. Except if it will give you sine theta over what? Cos theta. Cos theta over sine theta, whichever one. If it will not give you that, please don't divide. Even if it's going to give you sine squared, it's still fine. But anything sine over what? Cos, sine squared theta over cos theta, fine. Sine cube theta over cos cube theta, fine. So that you get what? 10. Please, make sure the right-hand side is a 0. Make sure the right-hand side is what? A 0. Please factorize. Take out your trinomials. You must know certain trinomials. Take out for certain trinomials. There are certain trinomials that you need to keep at the back of your mind. I'll probably remind you of some of those trinomials. Let's look at this one, guys. Let's see. What will I do here? Let's write it out. Please don't rush. Observe. Sine x cos x plus what? Oh, also watch out for your compound formulas. Watch out for compound formulas. I did some questions on the recent videos that I'm, the short videos that I'm doing. Please reach out for it. I'll probably reshare the trig one again. It's about 30 marks. It took me almost an hour just on trigs. Okay, I think I did share it. I think I did. If I didn't, I'm going to reshare it. And I'm actually doing the postings, just sending it also on TikTok so that you can have access to it. I did very, very nice questions there. Okay, let's look at this. Let's see something. Let's see something. Look at, don't divide, right? Make sure the right-hand side is what? A 0. Let's follow that rule. If we need to return it, we'll return, but let's follow that rule first. So if I'm following that rule, what should I have? Sine x cos x plus what? Sine x minus 3 cos squared x minus 3 cos x equals to what? 0. Keep an eye on things that are common. What do you think is common there? In the first two, sine x is common. So if I take out sine x, what would I have? Cos x plus 1. What's common in the second one? First is a negative, right? You see the negative there? Now, there's 3 cos x. Oh, beautiful. What do we have left? This cos x here. Now, negative would give you what? Oh, beautiful. We have 2 items here. And what is common to the 2 items? Cos x. Beautiful. Cos x plus 1 is common. The guy just walks in and starts showing up. Cos x plus 1 is common. Now, what do we have left on the first side? We have sine x minus 3 cos x, and that should be equal to what? We go back to just solve it. So what do we have? Cos x plus 1 equals to 0, or sine x minus 3 cos x equals to what? 0. We try to solve quickly. Cos x equals to what? -1. Okay, look, I have sine and cos. I want to take note of this. There's nothing common. There's no special angle. There's no compound formula. Let's move. Do you notice if you divide both sides by cos x, you go back to my first point. Never divide except it will give you what? Sine theta over what? Cos. So if I were to come here now and divide this by what? Cos x. Do you notice I'm not just dividing? I have seen that it will give me what? Tan. So what do I have here now? I have tan x equal to 3. I have two solutions there that I then need to decode. Is there anybody who would like to ask me a question on this? Guys, it's just 1, 1, 1, 1, 1. We don't have time to do focus on it. One thing only. We're just going to move 1, 1, 1, 1, 1 like that. And while you are studying, please let's use the group. If there's any question, just send it on the group. Don't send it personally. Reason being, I'm going to be quite busy. So when somebody sends on the group and you can assist. That's a way of preparing. Don't wait for the teacher. If you can, even if it is wrong, you see, you guys are afraid to get things wrong. That's the problem. I am never afraid to get things wrong. Just go and do it. If it's wrong, it's wrong. But I've made my attempt. When I'm corrected, I know, oh, this is what I did wrong. I won't do it again. But if you guys cannot get things wrong because you are scared, people would laugh. Let them laugh. God gave them a good gesture to laugh, you know. And God bless you because you make them laugh. You are a source of joy. Okay. I promise you, be a source of joy to people. Let them laugh. Yeah, you see, all of you are laughing now. I'm getting blessed. Okay. Now, what do we do from here? Cos x is -1. Let's quickly deal with that. Please, my good learners, I have been telling you this, and I'm repeating again. That negative only tells you the quadrant. Where is cos negative? Cos is negative second and third. Because here is what we're going to use. Students, take what? Coffee. And this here is your reference what? Angle. What do you have here? 180 degrees minus reference. What is this? 180 degrees plus reference. And the last one, 360 degrees. Don't forget these little things. So the negative tells me, oh, I'm in quadrant 2, and that's what the negative is doing. When I look for the reference, I am not going to include it. And if you put that in a calculator, you get a 0. But now, the sign has told me where to go. Quadrant 2 and quadrant 3. So what do? I go to quadrant number 2, which is 180 degrees minus what? The reference. What are we solving? X. So x will be what? 180 degrees minus 0. Plus k what? 360. And obviously 180 minus 0 will give us what? 180 plus k what? 360 degrees, where k is an element of what? Integers. The element of integers means all numbers from negative infinity to positive infinity except what? Decimals and fractions. Taking you back to what you wrote today. Yeah, when I say integers, I mean things like 0, 1, 2, 3, whole numbers. And then the negative part of it, -1, -2, -3, not -3.5. And question and Q3, do you notice Q3 will give us the same thing? It's 180 plus the reference. So what do you have? X equals to 180 plus 0, right? Can I just get my answer there? Yes, talk to me there.
So like my whole high school career, I've never really understood this K's 360 thing, sir.
Okay, so you want today to be the day that changes your career?
Yeah, so you have to, sir.
Okay, So when we do this, this is what we're saying. Look at the word. The word says what? General. Right?
Yes.
So general means we have a million solutions because it carries on from negative infinity. That's why we're saying, give me one equation that represents the whole thing. So we will then write, that's why we write 180 degrees. This 360 actually comes from the fact that the sine graph and the cos graph have a period of 360. It repeats itself every 360. So when I then say k is an element of integers, my real answer would be 180 degrees. But what are the other solutions, other values that will give me the exact same value? Does that make sense?
Yes, sir.
For example, check. If I replace my x here with 180, I'll get -1. I am being specific there right now. Because 180 would give me what? But what are the other values that will give me -1? I will now come here and say, okay, k is an element of what? Integers. Let's make k 1. So I'm going to have 180 plus what? 1 times 360. And what's that answer? 540 degrees. It means another solution would be what?
540.
Let's try it. Let's try it. Cos 540 equals to that, -1. Can I go further?
Yes,
You see, I can then say k is 100. If k is 100, come, let's play. Let's have some fun. It's been a long day. It's been a long day. It's what? 3,000? So we have 3,600, right? No, 100. Bro, 36,000.
Oh, yeah.
All right. Plus what? 180. 36180 degrees. Come, let's go check. What is cos of that? Cos 36180 -1.
wow.
I can then continue. K is 5,000. K is 50,000. K is 100,000. So I can say k is a positive. I can also say k is what? A negative. That's why we say we want one solution that represents what? All solutions. Meaning general what? Solutions.
Thank you, sir.
All right. So for the first time in your entire schooling career now, something makes sense. The only time that we would have to put k in is if the examiner gives me a domain. All right. It must lie between this and this. That's when you start putting in the k value to check. So once I see a domain, it's no longer general. It's now specific. To say, okay, the examiner says but x lies between -270 degrees. I cannot leave my answer like this anymore because this is general. Now I'm saying, give me answers only where x lies right here. So what do? I start substituting 1. Whatever answer I get, I check, is it within this domain? If it's within this domain, I keep it. If it's not within this domain, I chunk it away. So once I see a domain, it's no longer general.
So do you write your answers or do you write what you put as k?
No, you write your answers. You write your answer. Maybe, for example, I'm just saying, if 200 works, then x will be equal to what? 200 degrees. I am now being specific. It's no longer general. General means we want something that can get me so many. All right, that one is done. Next one. What is it? 10x equals to what? 3. Now, for 10, the period of 10 is what? 180. And where is 10 positive? Because we're looking at the positive 3 here. Quadrant 1 and please, for 10, you only do quadrant 1 and quadrant 2. If it is positive, quadrant 1. because quadrant 3 will be the exact same value. Do you notice that, guys? Whatever angle I choose here, let me show you something. Choose an angle here, 20. Add 180 to it. You'll come here. So whatever is going on here, it's exactly the same thing going on here for 10. So for 10, if it is positive, there is no need to waste time of doing quadrant number 3. You just do quadrant what? 1, because it is repeated. Because you are saying plus 180. Once you say 180, you are jumping from quadrant 1 to quadrant 3. So what's my reference angle? If it's negative, you only do quadrant what? 2. So put a note for yourself there. If tan is greater than 0, that is positive, only quadrant 1. If tan theta is less than 0, only what? Quadrant 2. That's how we learn. Put notes. Many of you want to remember all of these things. No. I remember because it's years and years. I say the same thing every year, like a record, like a tape. So I'm bound to remember. Some of you, by December, if we ask you what is tan, you say, what is that? Is it a color or what? Because you just want to write the exam and disappear, you know? But I know I need it next year again. So I have to remember by all means. Okay, so arc tan of 3, what is the reference angle going to be? 5, 7. But now it's positive. I'm only in quadrant what? 1. So what would it be? I'm solving for what? X, right? X in the first quadrant, Q1. What is our reduction? Reference. What is my reference? 71,57 degrees plus K what? 180, where K is an element of integers. And with that,
we should put a normal Z,
it's fine. Put a normal Z. Put a normal Z. Guys, are we okay? Are we on the same page? Hello, my YouTube learners. It means the guys on YouTube are true followers, because I didn't say I was going to put it on YouTube. They are true. Yeah, that's been a true subscribe. That's a true subscribe. Okay, guys, are we okay? Everybody okay? Please, we want to get general solutions. Guys, the reason I'm doing this today is tomorrow you're locking yourself in and work on your own. Is that okay? You're locking in, working on your own. If there's any challenge, hey, guys in the group, come. Sometimes when you're working on your own, you find something interesting. Please also share. Don't just share challenges. They're interesting. So like, oh, this question. Ooh, I just love it. Share. You know? Don't be, I don't want to share. I don't want to share it. If it comes out, I want to be the only one. You are not the only one. There are 500,000 other learners who have seen that question. Okay. All right. That's general solution there. And by the way, huh? I've not really had time. Was it coding?
It wasn't coding as such, but it used
similar experience. All right, guys. Do you want to prove this identity for me, please? Ooh, okay, guys. Forget about that one. Prove this identity. 3 marks. This looks yummy. I don't even know what to do now, but I'll give you a chance. Huh? You look like some peanut butter stuff here. Give you 5 marks. Come.
The way that you showed us with the
Proof. Don't waste time. Don't waste time. All right, guys, it's a very tricky one. Very tricky one. Let me walk through with you, and I'll tell you what came to my head and what I did. Okay, I know you're trying to. Actually, I'm seeing sin 3x, and I'm thinking there's no identity that has cos 3x. Okay, 1 second. Okay, guys, sorry, it was just a call very quickly. Now, look at what I thought. And you are allowed to think creatively like that. So I'm starting from the left-hand side. But there's no magic that I know that will bring that 1 plus cos 3x up there. So I'm going to do this. I'm going to take it there myself. 1 plus cos 3x.
Oh, that's very good.
Because I have not changed anything. It gives me 1 still. So by force, I have forced that 1 plus cos 3x to go up. Now, if I simplify, what do I have? So it is skill. And that's why we do questions, to expose us. Cos what? 3x. Over. Do you notice this is difference of 2 squares? So it's rationalization. What is this? 1 minus cos squared what? What is it thinking? But how is this going to lead us there? There's no 1 at the bottom. What is 1? Sine squared plus cos squared of a particular angle. So I would bring that in. Sine 3x, 1 plus cos what? 3x over sine squared. I have to maintain 3x plus cos squared, because that will give me 1. Sine squared theta plus cos squared theta minus. What do you notice? That guy falls away. Do you notice there's only 1 sine 3x on top, and there are 2 at the bottom? Because it's a squared. So I'll get my answer as 1 plus cos 3x over what? Sine 3. Don't cry. At least now you have been exposed. So the idea is exposure. If you see something like this now, at least even if it won't work, you will try it first. All right? Because it's a rationalized thing that I'm seeing up there. So the next time you see the thing, but we tried it once and it worked. Let me also try it. Even if it won't work, I'm sure you'll have been closer to your answer. Okay. Guys, for which values will this be undefined? For us to have something undefined, please, is that your asymptote, basically? We're saying the denominator should be equal to what? 0. So don't forget that. Undefined. Let's quickly talk about undefined. Let me give you a crash course on undefined. Number 1, denominator should be equal to what? 0. Number 2, if the expression, I don't know if you remember what I want to write here, contains 10, think of the asymptotes of 10. Let me say tan k theta. Think of what? Of the asymptotes. Tan theta. For example, what is the asymptote of tan theta? Tan 90. Tan 90 will give you error, right? So if the expression contains tan 90, one of my answers will be what? 90 degrees, right? Plus k what? 360 to give you all the values. But if my expression contains what? Tan 2 theta, the idea is to get this guy to 90 degrees. So it means theta will be what? 45 degrees. Because when I say 2 times 45, it gives me the 90 that I want. Oh, sorry, K180. Also, you keep that here. For example, if the question had tan 3 theta, then theta becomes what? 30 degrees. Why? If I put 30 there, I'm going to get 90, which is my asymptote. I hope it makes sense. What about tan half theta? What should theta be? Half of what will give you 90? People, use calculator for that. Yeah, but I mean, half of. Guys, are we okay? That's my quick one there for undefined values. Now, what are we looking for? What's our denominator here? 3 sine 3x. Lovely. So we are saying sine 3x should be equal to what? 0. What are the values? By the way, they gave you a domain. They said x must lie between what? 0. Is it 0 and 60? Okay. What would you do there? What are the values that you will substitute? Guys, if you can do this manually, just you can put your calculator in there and get 0. There's no need for this, but you need to get what? 0. I can use my calculator though. Look, sine 0 is 0. That's the first thing I'm going to think of. Sine 0 is 0. So what do I have? Okay, but let's check something. What's my reference angle? Arc sine of what? 0, which is 0. Let's solve for 3x. Huh? Negative? Dude, between 0 and 60. X, whatever x you get, it must be between 0 and 60. So 3x is 0. Check your first answer. X equals to what? 0. But look at the problem. Okay, no, let's do this. Let's do this. This is 0 plus k what? 360, right? By the time I divide, what do I have? 0 plus k 120. But do you notice all these answers are still bigger than what? I only have one answer, which is 0. Look at this. I want to confirm this answer. Let's do something. What does sine 3x mean? There are 3 graphs in the space of what? I want you to see something. 360. There are 3 graphs. 3 complete what? Graphs. Okay, what's the maximum? I want you to see this k issue. What's the maximum? 1 and -1. Let's draw 3 graphs. Okay, let's try it. If you are drawing 3 graphs, it means 1. That is the K120 that we spoke about. That's why you have 120. Because each period, look, graph number 1, graph number 2. That is your sine 3x. Does that make sense? What will be your halfway here? 60. Does that make sense? 60, 120. What would this be? 180. Huh? 300. Okay, where am I getting 60? Where am I getting zeros? I'm actually getting 0 here. So my answer should be 0 and what? 60 degrees. So the graph pays if you understand the graph. If you put a graph, if you put 60 here, what are you going to get? 180. And sine 180 would give you what? 0 from the original graph. So please, let's learn also to use the graph. I hope it makes sense. 3 graphs in the space of what? 360. And I'm looking for where I'm going to get 0. So I have 2 answers, 0 and. So this is where they're going to mark you. They'll mark you here for equating to 0, and then mark you there and there. Did that make sense? Guys, did that make sense? Very, very important. That's where the period comes in to say K360. Yes, my lady?
Hi, sir. So I'm
Hi,
not
ma'am.
understanding the 60.
The 60.
Yes.
Okay, do you understand the 3 graphs?
Yes, sir.
Okay, check here. That's a full graph, 120, right? Do you understand that one?
Yes, sir.
Yeah, that's halfway. If I ask you to calibrate, this is half.
Yes, sir.
The full graph is 120. And that's half of the graph. Do you see the 60?
Yes, sir.
So that's where that's why all of these are 60, 60, 60.
Oh, okay.
So the gap is 60, 60, 60, 60, 60, 60 there.
Okay. Thank you, sir.
Yeah. Otherwise, think of what would give you, just like we did in time, think of where you are going to get what? 0. What are the values that will give you 0? Sine 0 would give you 0. Sine 180 would give you 0. Sine what? 360 would give you what? 0. Now divide all of this by what? By 3. 0 divided by 3, 0. 180 divided by 3, 60. 360 divided by 3, 120. But 120 is outside your domain. Are we okay there? All right. So think of what would give you 0 and equate all of that to what? 3x, 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 and then solve. Okay, beautiful. So denominator must be equal to 0. Lovely. 18 marks in the bag. Come, guys. Oh, I'm beginning to love trigs. Please get me these first 6 marks. Come, let's push. I know we're tired, but let's push. This one without the use of a calculator. This is baby work. This one we get without, if they didn't tell us to find the abscissa of this, then it will be fine. Otherwise, I think you did it in grade 8. You did. It's in your grade 8 textbook.
When you substitute the 4, right?
That's your x value.
Yeah. If you substitute the 4 into the equation, it doesn't make sense.
It does.
No, it doesn't.
I did it.
Because
Okay, all right. Focus on this one. Focus on this one. But I did it. But there was no reason to bring such words. I haven't used that word in the past 15 years.
But everything else is fine. When you look at it, like, why?
Okay, John. Hi. All right, guys, do you have an answer for me? What? Cos 2. Okay, can we confirm? Now, lady, you agree with cos 2 theta, you overheard. The ears are Doppler ears.
So I got cos squared theta.
Okay, guys, now lady says she got cos squared theta.
I'd like to argue with my lady there. Oh wait, no, I just said
Okay, guys, can we share answers? Is it cos 2 or cos squared? Mohammed also said cos 2. Yeah, what did you get? Now, let me just check how you were writing. Make sure it's a so that we sure. Okay, but let's run through together quickly. Let's run through together. Now, 10, guys, 10 is already an acute angle, so let's leave it. So what would that be? Sine 10 over. What is cos 440? Okay, you are too smart for me. Cos 440 equals to that. Shift cos answer, which gives me cos 80. Okay. I know you are too smart, just wait. Okay. Plus, anywhere I see 360, I cancel it and I put a 0. All right. So what would that be? 0 minus theta of what? Tan negative theta. And tan negative theta is the same as what? Negative tan theta. And what is sine 2 theta? 2 sine theta cos what? Theta. Okay, now I can bring in my co-functions. So I can change my cos 80. Please remember your co-functions. If the 2 would give you 90, then we can change the trig ratio. Now, what would this be? Minus sine theta over what? Cos theta multiplied by 2 sine theta cos theta. Let's put over 1 for clarity. So this give us 1 minus 2 sine squared theta. And that should, if you check your formula page, that should be cos 2 theta, not cos squared theta. Now, Lady, please use your formula page.
Yes.
Where did you make your mistake?
I put the instead of the 2, so
The what?
I placed the squared instead of placing 2 in front.
All right, guys. So this is, I want us to, when we see this question, let's just rejoice and get them correct. There's no way they want to set this one that, yeah, it's always going to be something very straightforward. Know how to reduce. There's no, I don't know what other way, except I'm the one certain. I think this examiner just thought of me, this paper one examiner, set like me. But I wouldn't do this, no. But well, they are doing drugs. That's the department for drugs is DEA when I watch movies. Yeah, DEA. Okay, guys, let's look at this one. Given that we need to increase the pace, let's increase the pace. We still have Euclidean. And Euclidean, I want to see if we can get through the proofs as well. The proofs you can learn on your own. Sine, given that sine 60 plus 2x plus sine 60 minus 2x, okay, that. Calculate the value of k if sine 60 plus 2x plus sine 60 minus 2x is k cos 2x. What is going on? Okay, we're looking for the value of what? K. All right. So they are bringing this sine to what? To cos. But I think I see, what do you see? I see my compound angle formula. I'm seeing sine A plus B plus sine A minus B. Guys, I wanted to try. I wanted to give it an attempt. That's what I'm seeing. I hope it works. Sine, that is sine A plus B. Expand it. And then expand this one. You have the formula. Let's try. And then simplify to get that at the end. Because some things will cancel out. Some things will definitely cancel out. Let's try. Unfortunately, I won't be able to interpret for you when you write. but that's going to be my first attempt. Five marks, just because of the length of the work that will be done. Okay, guys, anybody wants to share what did you get for K? What did you get for K? Anybody sharing? Quickly, let's move. 6:30, I think. Let's try to go to Euclidean. So we have 20 minutes, but we have graphs and that. So let's run. Okay, what I would, like I said, that's what I would do. You know, I would break that down. I know that that is sine A cos A, right? So that would be what? Sine 60 cos 2x plus cos 60 sine 2x. Now, plus the same thing, but the sign changes now. Sine 60 cos 2x minus cos 60 sine what? 2x. So if you notice this, which one? This and that cancels out. So what do I have? And this are the same. So what will it be? 2 sine 60 cos 2x. And what is sine 60? Root 3 over 2. And that gives us what? Root 3 cos 2x, which means k is root 3. Use your formula page. Use your formula page. All right, let's look at 6.2.2. If cos x equals to root t, without using a calculator, determine the value of that. Want to give it a try? Okay. Not just because of the way it looks. Now let's try. We can try. Remember, look, let's try. Let's not get it. Let's see what it would be. But you know that you know something. I don't need to do the whole thing because I already know that this that is in the bracket is actually what? Root 3 cos 2x. I don't think it's, yeah, root 3 cos 2x. Make sense? So if that is the case now, so you take it from there now quickly, just try to work 2-3 minutes. What can you just solve normally? Tan 60 multiplied by what? Root 3 cos 2x. You want to make sure you get a cos x. That's a double angle formula there. What is tan 60? Root 3. Okay, so root 3, I'm already doing it for you guys. Now, what is cos 2x? No, don't bring in a sign. I want to get that. It is 2 cos squared x minus 1. 2 cos squared x. Please use your formula page. Root 3 times root 3 would be what? 3. What would this give me? 2 cos squared. Now, if I expand, what do I have? 6 cos squared x minus 3. And what is cos x, by the way? Root t. So what would this give me? Root t what? Squared. Because cos x is root t. So what do I have? 60 minus 3. They said in terms of t. So don't give up. Just try something. Are we on the same page, everybody? Are we on the same page? Henry, are you lost?
But sometimes you don't have to solve for t because you see terms of t. You get the value.
The answer must have t.
Oh.
Determine the value of that in terms of t. That means your solution must contain the letter t. They don't know. They're not asking for what the value of t would be. Are we on the same page? We're good? Okay, let's run. Let's run quickly. If you have a chance, you can still watch this whole thing tomorrow. Because I think we're actually picking up some nice questions there. Which you chose this paper, the beautiful one. Okay, come, graphs. Let's see. Okay, what are we looking for? Okay, let me cut out the graph alone, and then we'll take the questions one by one and try to increase the pace. I don't remember ever doing this paper. Huh?
days. The kind of people that you're gonna
Good. Yeah, I know I would have, but I don't remember like me going through.
gonna tell you which aspect was.
But now that I'm seeing certain things, it's flowing into my memory now. If I need any of these, I know that I need to come here. Okay, guys, let's continue with this question and look at this graph together. Let's just enjoy and relax with maths. In the diagram below, the graph of half cos x, we can relax. And g of x equals to sine x minus 30 are drawn. Interval is from negative. Please just draw a sketch. I gave you table for steps. Steps are important, but we're not sketching this time around. Okay, guys, let's move. I'll give you that table for those that were not in the class when we did that. Determine the length of AB. Come, guys. Where is A and where is B? Oh, please try. Just the way you do functions. What is A? No. What can you see? What's happening at point A? Yes. And y-intercept, what do we know? X is 0. So you substitute that in F and you substitute that in G. Please give me an answer for the length of AB. 1 unit. Let's confirm. I need answers from everybody.
1 unit.
Confirmed? Both of us at home, talk to me. So what do? We know that the X value there is what? 0. How many marks is this? Okay. So you would notice which one is, basically they are telling you F minus G.
Yeah.
It's basically F minus G.
Actually losing
And we know that X value is 0. Okay, guys, let's solve. F, what is F? Half cos X. I didn't get answers from those at home, so I'm not sure. I'm waiting for, oh, thank you, Ratili. All right. So basically, AB is F of X minus what? G of X. So let's put our answer there quickly. AB is F of X because F is on top. Do you remember the equation? Half cos X minus sine X minus 30. And we know that at that point, X is what? 0. So I believe you. Your answer is what? 1. I believe you, and I move on. So guys, that's what it means. Top function minus bottom function. Number 2, write down the range of what? 3 of f of x plus 2. 3. Okay, come, let's do this. You do this quickly. The range. Remember what f of x is? F of x is what? 1 over 2 cos x. This is what I can tell you quickly, just as a hint. Cos x lies between -1 and 1, the original graph of cos x. But do you need that? No, don't let me confuse you. Okay, find the range. We're looking for the range of that new function. 3 f of x plus 2. 3 f of x plus 2.
Can I look at my answer between 1 and 3?
Between 1 and 3. But yeah, you still need what I wanted to write, because x lies between -1 and 1.
Yeah. Write it down and just manipulate.
So basically, if I say 3 of f of x, so let's replace 3. What is f of x? 1 over 2 cos x plus what? 2. What would that be? 3 over 2 cos x. Now, what is the minimum value of cos x? Minimum of cos x is -1. Come here and throw negative, excuse me, -1. You take your answer back. What's the answer now? 3 over 2. That would be 2 minus 3 over 2, which is half. And the maximum of cos x is +1. So what do you have? 3 over 2, which is what? 7 over 2. And what's our range? Smaller number first, less than or equal to. So please put range is always the minimum, less than or equal to y, less than or equal to what? Maximum. Guys, let me know if it makes sense. For cos, let me quickly give you this. This is important. Let me give you this. For your sine x and your cos x, they lie between what? -1 and 1. For your sine squared x and your cos squared x,
Oh, I don't know that.
this one, guys, for the squared ones, it lies between 0 and 1. And for tan x, it is -infinity to positive what? Infinity. Please, this is very, very important. Once I put a square, then I get a 0, because the negative just cancels out the other negative. That's what it is. Yeah, no matter what it is, it's -infinity to positive infinity. If the examiner is feeling nice and they want to give you free marks, they'll ask you for the range. Just look at the graph. If you remember the graph, that snaky graph that goes up and down continuously. Okay, guys, I hope this makes sense to us. All right. Good. Remember, we're trying to touch so many things. Read off from the graph the value of x, for which v of x minus f of x is what? √3 over 2. Read off from the graph the one g of x. Now, when they do this, it means g of x must be on top, above. F of x must be at the bottom. And we want what? √3 over 2. Read off from the graph. F must be what? On top. And g must be what? Below. So can we read from here? What is √3 over 2? Let's change √3 over 2. Now, what is √3 over 2 in terms of value? 0.866. Put √3, guys, put √3 over 2 in your calculator. What does it translate to in terms of decimal? It's 0.866. Good. This unit here, what did you get for this unit? We got 1. So 0.866 should be what? Smaller than 1. Which means I can't be moving towards the left-hand side, because I see it's becoming bigger. I should be going towards so my answer lies somewhere between 0 and somewhere 45 there. My answer lies, okay, this is what I'm thinking. We'll find out, because they said we should read off the graph and then we'll test it. If this is 1, this is how big 1 is. Do you notice this is bigger? So I don't think I have a business here. So In the meantime, smaller. The distance is becoming smaller until it gets to 0 here. Here, the difference is what? 0. So my answer should somewhere lie here.
But it can't be past 30 because even 30 is a bit too small.
Okay, fine. So what I will do is, let us check 30. Put 30 into f of x minus g of x. We have that equation. Put 30. Let's see. Or basically, if I put 30 here, oh sweet, I think it can be 30, because if I put 30 here, this is 0. Now what is sine 30? What is cos 30?
Yeah.
What is cos 30?
Because 30
Root 3 over 2.
yeah.
So that will then give us root 3 over 4. But we want it to be what? Root 3 over 2.
It's somewhere between 0.
Somewhere between 0 and 30. Wait, let me read again. Read up from the graph a value of x.
G of x minus f of x. You're doing it upside down.
What are we doing?
F of x minus g.
Oh, we're doing g of x. Sorry, I'm misleading you, but we get the whole idea. We get the whole concept. I think it's 90.
Yeah, it's only possible.
Yeah, but you have an idea now, right? So, because see, they say without the use of a calculator, what is, I'm thinking my answer should be less than 1. The best thing here is to think of this. Do you see a 0 here? Because 1 is a bit higher, just a little bit higher. So if I throw in 90, I'm sure I'll be getting that.
Negative root 3 over 2.
Negative?
Root 3 over 2.
Okay, but it's a length.
Yeah.
Since it's a length formula, length has no. Guys, are we okay with my 90? Okay, so I was misleading you. I was looking at what? F minus G, but the concept is what I needed. And that's why I asked you what is the value of root 3 over 2. You need to see whether it's greater than 1 or less than 1. It gives you an idea of where to look. So I'm looking at a place that is smaller than what? 1.
Since this is read of a beta, it has to be either 91.
Yes, because we can't be speculating.
Yes.
Are we okay, everybody? Answer is 90 degrees. Did that make sense? Beautiful. Beautiful. Let's just enjoy maths, you know. I still repeat that. Maths is still okay. For which values of x? Okay, now guys, 7.4.1. Please try to get this for me. Do the exact same thing you were doing in paper 1. All right? F of x multiplied by g of x is greater than 0. For it to be greater than 0, I need something positive, right? Where do I get something positive? Positive and positive, negative and negative. And my domain between negative 90 and 240. Oh, the whole graph. Okay, come, give me an answer. Where are they both positive and where are they? Please, I want you to write this answer. Write the correct notations we want to mark. Where are they both positive and where are they both negative? Come, please.
Oh.
What does derived mean? Damn, that's it. Gradient. Don't derive. It's the implication. Okay, what's our answer? Where are they both above and where are they both below? They are both below here. All right? Up until this point. Oh, sorry. Don't laugh at me. Okay, where are they both above? I think from here to here, right?
Here.
Okay, the x-intercept will always give things away. So they are both above between 30 and what? 90. And then where? Between 210 and 240. So those are my answers. They are both above between 30 and 90. And they are both below. So let's write the answer because we're using the word betweens, right? What would it be? Between 30 and 90, right? And what? Are we on the same page? But I want to do that. Wow. The examiner is also telling me that 240 is inclusive. Now, if I go to 240, let's go to the graph. What's happening? At 240, that's my 240. They are both what? Negative. So that's a silent one mark that could be lost. Because those values are also part of the domain. Silent one mark that can be lost. Okay. What are we looking for now? The derivative. And what does that mean? That is just telling you what? Gradient. If the graph is shifted 5 units to the right. Okay, let's forget the 5 units. Where is the gradient? Positive. Let's go back to the graph. Oh, which graph, by the way? G. Okay, which one is my G? All right. What's the gradient here? Negative. Negative. Turning point, 0. Gradient here is positive, right? Here, 0. Gradient here? Very easy. You just know how to interpret. So where's the gradient positive? Take care. It's right here to there. Does that make sense? So gradient is positive from what? Negative 60 to what? 120, but not inclusive. All right. So negative, please let me know if we are on the same page. Negative 60, oh, negative 60 degrees to what? 120, right?
Yeah.
Okay. But what are we doing to the graph? 15 where? 5 units to the right. Which means this then becomes what? Not 65.
Yeah, because you're moving, yeah.
Because we're moving towards the right. This becomes what? 125 degrees. Just application. I don't know if it makes sense. Please let me know. This is g prime of x greater than 0. This is g prime x minus 5. Because we are moving towards the right. We're moving towards 0 from the negative. Let me know if it makes sense. That's a beautiful question. Beautiful. Beautiful. Come talk to me, everybody. My YouTube learners, are we on the same page as well? So whenever you see those things, forget about the shift. Deal with the original first. Now apply the shift on the answer. Okay, let's push. Let's push. I think we're done with graphs there. Okay, 2D and 3D. Do we still remember the rules? Sine rule, cosine rule, and guys, let me tell you quickly what to do somewhere here. Okay, sine rule, cosine rule, and what? This is what I'm going to quickly write for you. Let me do a short 3 minutes D and what? 3D. First thing, number 1, split the triangles into what? 2D shapes. Always. Number 2, for right angle triangles, what do I use? So, Toa, and Pythagoras. Right? For non-right angle triangles, that's where I'm going to bring in what? Sine rule, cosine rule. Okay, but okay, let's do it. This is what I want you to remember. What is cosine rule? A squared equals to B squared, C squared. When do I use it? If you remember my words, split that into two, just to tell you when. The small letters represent what? Sides. So when do I use it? When I'm given three sides. And then here, when I'm given what? Two sides plus included what? Angle. If this one will not work, sine rule. Once I see that I don't have three sides, or I don't have two sides and an included, then I just leave cosine rule on its own and go to sine rule. I don't have to even remember when to use sine rule. If cosine rule will not work, it's only sine rule. And then my area rule. Remember, we're still going to do this under Euclidean geometry. Half AB sine C. When do we use this? Also when we have what? Two sides and an included what? Angle. Come guys, this is all you need to remember for 2D and 3D, and life becomes very easy. Split the triangles. Don't be a genius. Say you want to look at everything at once. Split it. Label it correctly. Know which one is the right angle. Know which one is not the right angle. If it's not a right angle, think cosine rule first. When do I use cosine rule? Three sides. And do you see the way I did it? You don't need to cram it. You have A, B, C, small letters, three sides. The next one, two sides. Somebody is saying included angle, but I don't understand. This is what I mean. Check this. If I draw a triangle, it naturally just falls into play. The side facing the angle A, small a. The side facing angle B, small b. The side facing angle C, small c. Now check. What do I have? B, C, and cos A. Look at it. Small letter B, small letter C, cos A. The angle is sandwiched in between the two sides. And when you're using your area rule, you work just like that. Especially area rule because we need it under Euclidean geometry again. Okay, let's move quickly. Did it make sense?
Yeah.
Very, very basic. You know, once you understand this, can I move here? Okay, check, guys. Figure one, please read. I know you have already said you have already gone to calculate the length of AB. Let's read because it looks very hectic. Figure one shows a ramp leading to the entrance of the building. Oh, now it makes sense. But honestly, I read it, it makes sense. I thought of a building and, now I can, relate to it. ECD lie on the same what? Horizontal plane. Makes sense. That is the ground. You don't see it. Okay, think of the mall. We go over this on the mall. That is the ramp. So we are going over this. So you are coming here. So that is the ground. Okay. The perpendicular height, guys. Anytime I see the word perpendicular, it's about 90 degrees. Of the ramp is 0.5. And the angle of elevation from B to A is 15. The entrance of the building AE is 0, now you can picture you're driving over or something, lovely. Calculate the length of AB. Please, everybody, split the triangles first. Come, let's split it. Split it. How many triangles do we see? Triangle with information, please. Don't just be drawing triangle. Triangle with information. Let's draw. This is a workshop to see if you can really pick the triangles. All right, once you're done drawing the triangle, try to find the length of AB. Where do you have AB? Label the triangles, your own way, 1, 2, 3, 4, 5, whatever. But I can see where to find that quickly. Share your answers if you're done. One comma. Okay. Kian, do you have an answer? Come, please. All right. So I'm drawing quickly just to give you a chance to finish your calculation. ACB there. What do I have here? 0,5, 15 degrees. Okay, and I think that's where I'm going to get my answer from, by the way. What am I looking for? AB. So that's all. Response. Sine. Because that's opposite and that's hypotenuse. Sine 15 is 0,5 what? But AB. So what is AB? 0,5 over sine 15 degrees. And you said your answer is what? 1,93. I saw somebody else also giving me that 1,93. All right, thank you. Huh? No. Okay, but you would have gotten it wrong. So it's not about the answer now. So please quickly fix it. You're so car to. Figure 2 shows the top view of the ramp. Okay, now we've moved away from. Now, how many triangles do you see there? Three square. Okay, good. I'll call this triangle 1. Why 4? Oh yeah, there's 4. But for now, I see there's 4. But let's see. I don't even think we would need 3. The way I'm looking at this thing. Because I see no information there. It says figure 2 shows the top. The area of the top is divided into 3 triangles, okay? As shown, 3 triangles. If BAE is 120, calculate the length of what? BE. Now, guys, look at which triangle are we using? Triangle what? ABE. Let's draw it out for clarity. Just for clarity. That's why it's not, when you draw it out, you reduce where you are looking. I don't know if it makes sense. We look at that, ABE. Where's the day is 120, okay. Angle day is 120 degrees. What do we have? Do we have AE? 0,915, right? And we're looking for BE. 0,915, and we're looking for what? Did we get AB? What was AB? Beautiful. So again, you just reminded me of something. Whatever answer you get, you write on it. Populate your. What do you see? Cos rule. Why? Because we have what? Side, angle, side. And the best way, a lot of learners get confused. Let me quickly help you. Use small letters. The side facing angle A becomes what? Small a. The side facing angle B becomes what? Small b. And the side facing angle E becomes what? Small e. Now adapt the formula. A squared, that's what I'm looking for, equals to what? B squared. The original one says what? C squared. But now I have what? E squared minus 2BC, but I have 2BE cos what? A. I think here grade 8 can even do this one now. Substituting 0,915 squared. What is our E? 1,93 squared minus 2, 0,915, 1,93, and cos 120 degrees. Don't forget to look for the square root with that. It's closed. We move. Confirm answers for me, please.
1,2.
Fatima says 2,52. Fatima, is this the answer you're giving me? Fatima, you have lots of papers to work with. Huh? Can you please type well again? Now, is also getting 2,52.
You sign instead of course.
So can I confirm 2,52?
Yeah.
Confirm. Thank you. One day also confirming. 2,52 what? Guys, you see that once you draw out, but once you're trying to take shortcuts, that's when we have problem. If you follow the rules, it becomes quite easy. You actually, a lot of people think, but you are wasting time. No, you actually saving time. That's how it works. But once you start doing shortcuts, you find you cancel. And calculate the area of what? BFD. Okay, now we're using the area rule, obviously. If BFD is what? Angle BFD is 75. BF is equal to what? FD. And what? BF is 5/7. They're just trying to play. Just put the numbers for us. I don't understand why these guys want to just write numbers, but still start asking us what is the first letter of the alphabet that is used in the country. Tell us it's A by yourself. I don't understand. Okay, look at this. This angle is what? 75. This is that. Do you already see your sine rule, area rule?
Yes.
Side, angle, what? Side. But let's label. What do we have? BFD. Check. Okay. But the examiner came and brought in ratios. BF is what? 5/7 of BE. I don't think there's any work here. Do you know BE? That's the question I'm going to ask. What is BE? 2,52. So BF is what?
9/5.
9/5. Okay, so what's our area rule? Area is what? Half. Remember, side, angle, side. Half what? BF, ABC, side first, FD, sine of what? Angle F, all that be. Half, 9/5, 9/5, sine what? 75. What are you getting? 1,56 units. Oh, since we know meters, right? Okay, beautiful. Check. It's closed. Guys, this is your this is the base entry level. Entry level. Please remind me. Time is gone now. I'm going to do one. There's one I want to do. It's from Limpopo. I'm going to do the video for you. Take some time. Just that one. That question is hectic. I'm going to try. Eh? You sent me a message.
Yeah, no, I will think of it.
Oh yeah, just remind me. Probably do it when I wake up tomorrow morning when I'm very fresh. That question is hectic. I remember doing something. Let's. I won't do it now, but let's just see. I'm not sure whether it's Limpopo 2023 or Limpopo 2024.
I think just don't open that chat.
Let's see. I'm not sure whether it's 2023 or 2024. But I want to take time to explain that. That thing was a bit.
This is one of the more easier and
If you know what you are doing, that thing can be difficult for anyone. But if you know what you're doing, there's not this paper. The question was not, yeah, it's this one. It's this one. It's this one. It's this one. Huh?
It's a square experiment.
Why just a square? Very beautiful question. Very beautiful. But so well, I'll do it, slowly so that we see. But once you understand the principle as well, we'll be able to get things done. Okay, guys, where were we? We're on this paper, right? Oh, lovely. I've done this one. I've done this particular question so many times, but okay, it's not about me. It's about you guys. Guys, where do we do this? Reading time. Please. Reading time. We'll try. And not that when you finish this now, you say, okay, I'm done, and there's still time. No, you move on. Euclidean is first by observation. If you notice, what can I see? All right. What are my 3 rules here? First, basic 3 rules. Do you remember? What are the basic first 3 rules of the grade 11 one? Number 1, find the what? Find the source of the angle given or required. And as I just have time, I'll just take one Euclidean question and send you 5 minutes video, 3 minutes. I'll just keep doing that, as I get time. Number 2, do you remember? Describe the nature of lines. Describe the nature of lines around the angle. This is where you start talking about which lines. I'm thinking of tangent. This is when you start talking about which lines surround the angle. Is it a tangent and a chord? Then it's tan chord. Is it a tangent and a radius? Then it's tan rad. You understand what I'm saying? Is it 2 radius? Then I know it's center. You describe the nature. Is it a parallel line? Then I know it's my front angle. And number 3, use what? The if statement. That's said so many times. To prove the nature of lines and shape of objects. Prove that it is a cyclic chord, whatever. Use what? Converse as reason. But I think I've mentioned this. I want to add something to it. Except for parallel lines. So when we prove lines are parallel, we don't say converse. But for every other thing, converse tan chord, converse that, converse this, converse. There's a question I'm looking for. I think it's free state temperature. I think it's free state 2022. But let's try it. Okay, guys, are we okay with these? Are just 3 basic rules that will help you deal with the grade 11 ones. Then the grade 12 one, we would see how to deal with those. But let's get marks from grade 11. Can we move to the question? Okay, beautiful. Oh, I thought we were taking a picture.
Oh, no, I'm going to take a picture of this. I can throw.
Oh, okay. In the diagram, DEF, please highlight your cyclic chord. Oh, no, but you won't be able to highlight.
Hey, sir, can I please just highlight my question?
Because your
I won't
question
be
is,
able to do this if I can't.
question, use a pencil
Yeah, I'm not going to highlight it. Okay, let's
to shade it.
Wait, still want to do marks in my paper
For what?
for today.
If
Yeah.
no, you can't, but it's not allowed.
But you're not going to lose marks.
But it's not allowed. What can you do? So since you cannot in your cases, just do something like this. I know it's not. We like it with the colors. It becomes very conspicuous. I also love it. No, but I think for paper 2, you can highlight. You can use colored. Yes, for paper 2, you can use colored pens. Because I remember there was a memo that was sent last year, and we're all fighting to say no, especially for maths paper 2, you cannot.
Yeah.
Yes, but I'll confirm. But I know that thing for maths paper 2, but don't just come in with very bogus highlighters,
This one.
All right. I like your cyclic code. I love to do that. Okay. All right. DE is parallel. Okay, I've covered the parallel line, so we need to make sure that is visible. And guys, you must know your theorems. There's no point in doing this if you don't know those basic theorems. Okay. T is the point on the circle. E is 42. Guys, you want to get me the 6 marks quickly. Determine DGF, T, and GF. Quickly. You have just 3 minutes. All right, 3 minutes. It's more than enough. 3 minutes is more than enough. Trace the source, describe the nature, and you'll be done.
Supplementary.
Are we done, guys? Are we done? Please talk to me. Are we done? Are we done? Alright, that means you are busy looking for everything everywhere. If you're not done at this time, it means you are searching everywhere. You're not following my rules. If you follow my rules, you'll get it. Look, I promise you, I have not thought about this. I'm only looking at it now. I've not found an answer, but it will take me less than 2 minutes to get all of this done. But you know,
I know you can make one.
so because I wasn't even looking at the board, I sat down there, I was busy doing something else. I'm looking for DGF. Wait, D, G, F. Already it's on the side of my cyclic quadrilateral. I am already done. Exterior is equal to what? Opposite interior. So if you don't know the theorems, you would suffer. That took us less than 30 seconds to do. So if you are not sure, please go back to my lesson where I did what? X doctors in Cape Town +1. And I think on our group, there's a picture where we spoke about 25. Yes. Yes. 25 theorem, 25 concepts.
Yeah.
It's please can you re-forward it?
Stuff in my maths book.
No, it's on our maths group.
The school one.
No, here. Somebody please find it. Let's go quickly. Let's go find it. It's right there. On my it says 186 pictures that we've shared on this. I know it's more because I've deleted a lot. If somebody can still find it, please. I'm going to pause until we find it. Those of you that delete all of this for you to take a selfie. Delete my pictures for you to take selfies. Yeah, they know themselves. Now we are looking for the information. I shared that information with somebody recently. Everybody, please check. If you find it, just quickly forward it because we've got quite a few new people that joined in. Who did I share this thing with? I'm just scrolling on my phone. Anybody, somebody, please help me. When did I travel? Fatima, it was shared on your school group. Fatima, are you still here?
Hi, sir.
Hi, Fatima.
Which school group, sir?
Oh, there's one group that we created when we were at your school, and I shared it with there's this short girl. She's a friend to the head girl.
Is her name Pilar Sande?
Yes.
Oh,
And then
okay, I think I found it.
you found it.
Yeah, I'll
Please,
forward it to the group.
I know my stuff.
Okay,
All right, thank you.
you're
Thank-
welcome.
All right. And there we have it. Oh, Fatima, you are a star. Everyone has it now. It's 25 concepts, only from grade 11. 25. So all the theorems are in there. There's nothing that is not there. So go and learn that. What is this? Exterior angle equals what? Opposite interior what? Angle. We're done. What about now? Once I do that, write what you have there. What is this? 72 degrees. Now what do I need? Angle T. Where is T? Where is T?
Yeah, okay.
All right. T is right here. T is alone. Check. Trace the source. Where does it go to? It goes there. Now, if I didn't write this 72, I was going to struggle. But I have written this 72. I know this as 16. What is angle G2? 56. We're done. 56 what? Degrees. Angles in the same what? Segment. Again, write it there. 50 what? 6 degrees. Next one, G, E, F. G, E, F. So I'm looking for this angle, right? This angle in between. Okay, what can you tell me? Okay, no, I'm looking for what? GEF. So this angle. But this angle is not connected to the parallel lines. However, the parallel lines can help.
Yeah, they can.
They can help. All right, check. Ta, ta, ta. It may No E. Bob just fixed it. Okay. You were saying Bob, the what cannot fix it. Bob just fixed it. Unfortunately, my YouTube, let me see if I can manage streaming it. Oh, we're still live. So, okay, good. We're still live. All right. Sorry about that. We just had a, let me just make sure. Okay, guys. You guys can hear me, right? Okay. We're saying E1 is 56. Just trying to, let me refresh this YouTube page and make sure it's there. Oh, we're back. Yeah, we're good. I just want to refresh it. Anyway, we're saying E1 is what? 56 degrees, right? And then what did we do? Angles on a straight line. Okay, so we said 56 degrees plus 72 degrees plus angle what? GEF should be equal to what? 180 angles on a straight what? Line. So what is GEF? 52. Okay, and guys, that's it. Trace the source and play around. If you don't do that, you'll be looking at everything, which takes a lot of time. Okay, let's run quickly. I want us to get to the grade 12 part as quickly as possible. Oh, there we go. Beautiful. Already here, you need to already see what's going on, that you are using what? Proportionality. That's very direct. Very, very direct. Do you want to try? Just try. Try proportionality. Just try. Let me give you how many marks? 10 marks. Give you 10 minutes. Just try. Everybody's try. Proportionality. Hi guys, are you winning or I need to quickly step in to save time? All right, let me step in quickly. And here you would notice that we are dealing with proportionality. Okay, let me take you through because of our time. Remember what I now do now becomes a seed for you to work on your own things. Like once I see a triangle with parallel lines, I bring in the theorem of what? Proportionality. Okay, let's read. In a diagram, the diagonals of a parallelogram. Understand the property of a parallelogram. Opposite sides are parallel and equal. KLMN intersect at what? P. Now, what can you tell me about P? P becomes the midpoint. So you must know that property of a parallelogram. P is the midpoint of KM, analytical geometry. It's also the midpoint of what? NL. Okay. R is a point, da 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 da. Okay. NM ratio MS is 4:1. NM ratio MS. Guys, please. Variables. Very, very important. NL is 32 units. So can I say this is 16?
No.
Yeah. NL is 32.
Okay.
But NP is the midpoint.
Okay.
So that's also what? 16. That gives me my 32. Okay. And TL is 12. Oh, great. If TL is 12, can I put a 4 here? Does that make sense? How I broke it down? Halfway 16, then they give us 12. Now, these are units. They are not ratios. That's why I'm not putting variables. Okay. Determine with reasons the value of what? The ratio of NP to P. Do you see I've done? It's 4:1. But what are the reasons? So I am looking for NP. But what are the things we wrote down? P is the what? Midpoint. What? NL. Do you know why? Diagonals of a parallelogram what? Bisect. Diagonals of par. We don't write parallelogram. If you remember grade 8. Bisect. Which makes NP is now what? 16 units. Does that make sense? Which also makes PL to be what? 16. Therefore, PT would be what? 4. NP ratio PT, which is over PT. What is NP? 16. What is PT? 4. What's your answer? 4:1 or 4. Doesn't. It's the same. Guys, did that make sense? Knowledge of parallelograms. Are we okay? Prove that what? KM is parallel to. Now, once they ask you to prove this, if statement. If KM, where's KM? Where's K? All right. If KM is parallel to what? RS, what should happen? Let's look at something. They are talking about sides, so we can't be dealing with what fun angles here. Is there a triangle that we can see that contains these two parallel lines? Look at my parallel lines. These are my parallel lines, right? I could actually work with this triangle. Does that make sense? Let me see. Can I work with this?
Let's just work with NTS because we already got
NT what?
NTS.
No, but if, oh yeah, so that's another triangle there, right? And this triangle has what? Parallel lines. Do you see that? So if these two are parallel, then the ratio here should be the ratio here. If they are parallel. Now let's go and prove that the ratios are the same. And I think they are the same. NP over PT. Now guys, if you are proving, please don't equate. You write them out separately. What is NP over PT? NP over PT is what? 4. That has already been what? Proven. Now, what is NM over MS? That was actually given. So do you notice that NP over PT is equal to what? NM for what? MS. They were both equal to 4. Therefore, can I conclude? Km is parallel to what? PS. What's your reason? Or RS? What's your reason? Converse proportionality what? Theorem. So let's learn to use the if statement. If they were parallel, then what should happen? Then you go and prove that should happen. And then you put in the word what? Converse. We okay? All right. Guys, everybody okay there at home? If nm is 21 units, determine with reasons the length of what? RL. Okay, let's create a fresh page. Quickly. I want us to find maybe one or two more on this. Oh, I said I wanted to check something, right? I said free state. All right, let's run quickly. If nm is 21 units, determine with reason the length of what? RL. Where's RL? Oh, beautiful. So we are told that this is 21 units. But do you realize that opposite sides of a parallelogram are what? Parallel and equal. So it means this whole thing is also what? 21. But we're looking for RL. Is there a triangle with parallel lines? I think I do have. Huh? 4?
Oh no, man, I see.
But no, you're cooking. You're actually cooking. Because this is X. Yeah, you're actually right. Just got a gaslight, bro. You just because. But I want you. Yeah. But we need to just write it in the correct way. Right? But I hear you. I hear you. I want to check if there won't be any assumptions there. Because I don't know whether this length is equal to that length. I'm just trying to, but let's see something. R? Yeah, because they are parallel. I'll say so. I'll say so. But let's work on something. I want to see something. I want to work on something. Because I don't want to work on that assumption. But do you notice that? Okay, wait. I see. There's a triangle that I wanted, but I was talking. Look at this triangle. Does that make sense? And because I already know that these lines are what? Parallel. So can I then say RL over KR should be equal to what? Is that fine?
Yeah.
RL over what? KR should be equal to what? CL over what? PT. Are we together?
Yeah.
Okay. Or no, but since I know that one as 21, guys, I want us to learn not to do too much work. Look, I'm looking for RL, right?
Yeah.
And I know that whole length. So let's just go that way. So that it reduces the level of work. RL, that's what I'm looking for. Do I know the whole length? KL, does that make sense? Yes. Equals to, now what would it be? TL over the whole length, PL. What's your reason? Proportionality what? Theorem. Remember, you must tell me the lines that are what? Parallel. K what? M. We can still use that. Parallel to what? RS. Do I know RL? No. Do I know KL?
Yes.
21. Do I know TL? 12. Do I know PL? 16. The whole length. Yes, talk to me. Okay, can we do the math? Do the math plus multiply and divide? Huh? 15.75. Are we on the same page? I think Orasli was sending me an answer. Yes, Nalidi also confirmed. 15, what? 75. Is it meters? Units. Now, I want to say something. Okay, I hear what you said. It's right as well, right? Yeah, because that should also be x. If 4x equals, because from here we're matching 4x and 21, right? 4x equals to what? 21. What is x? 21 over 4. All right. So if this is 4x, this whole thing here is also what? 4x. If this is x, this is what? Yes. That's actually correct because it's ratio 1 to 3. So RL would be what? 3 into 21 over 4. What will give us what? Because it's 1 to 3. Beautiful. All right, guys, that's how we work proportionality. Keep searching for triangles. Please learn these proofs. I'm not going to do proofs. Okay, come, let's do this. I think I'm loving this one. Please, guys, learn your proofs. Please, 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 please. If I teach you the proofs now and you still don't write it, it doesn't help. You know, you just be watching a cinema. You need to write it on your own. Let me ask you, how many proofs are we doing? 7. Is that sure? 7. Very easy. Take 2 for dinner tonight. No, you can do 2 simple ones. Do 2 grade 11 ones. Angle at center and tan chord. Just repeat it. Master it. Don't read it. Write it. Write 2 simple ones tonight. You know that those 2 are done. There are 7, right? Tomorrow is Saturday. Breakfast, lunch, dinner. 2, 2, 2. But those 2, you are repeating them to make sure. You see, you don't want to burden your mind. You're just doing it at leisure, you know. When you are bored, just prove. You are bored, just prove. But by the end of tomorrow, you must know the 7. You don't want to wake up on Monday morning. What is angular tense? No. By the end of tomorrow, those proofs, it's already 5 marks. You have 5 over 150. Or 6. All right, guys, let's do this one. But it's very important, please. Yeah, because you know what? You're going to assume that I know it. When they ask me to prove it now, you find that something is missing. I know it. All right, guys, the reason why I want us to learn all of the proofs, you see questions like the last one, they are always there's no guarantee on that thing. Okay, but let's go read quickly, everybody. All right, in the diagram, O is the center. Please make sure you read. O is the center of the circle passing through A, B, C, and D. EC is a tangent. You know what I would do? Just label it quickly. EC is what? A tangent to the circle at C. Diameter DB. Diameter. Please pause. Don't continue. What's a diameter? DB. Already, I know that angle C is what? 90. See, I'm fixing things there.
And we got 10 raised.
And we also have 10 right there, right? Let's use the red. Okay. All right. F is a point on EC such that BF is perpendicular to what? EC. Where's BF? Oh, BF is perpendicular to what? EC. That they give us, that is F1 is 90, right? Radius CO produced by sec AD. Check. There's a theorem here. I don't know if you see it. No. Line drawn from center that bisects the chord is perpendicular. You need to learn how to prove that. It's part of the proof. That's 90. Okay.
can also put parallel lines because FB and CO.
A parallel. Lovely. We're going to need that. Corresponding angles here.
O is equal to O.
BO is equal to OG. Fine. That's radius. Radius. Also what? Radius here. It's just label around. You'll find things just playing a role. You see, we've not even rushed the question. We just read, what is it that I can write out? What can I bring out from the statement? And write all of those things. Your brain is too fragile to remember all of them, but your pen is never too faint. Write them down. Okay, we're not going to solve all the whole question now. Why?
Angle from a chord.
Okay, don't force things that let's just walk around very obvious things. We don't want to solve the whole question now. We just want to quickly write basically. Then we go now. Prove with reasons. FB parallel to C. That was done. How did we prove that FB is parallel? Now you're trying to remember what you used. Oh, but immediately I did this, do you notice? We are now done. But what did we write? What was not given? The red one was not given, right? So what do we prove? We prove that angle what? ECO is what? 90 degrees. What's your reason? Tan rad. So let's write that. That's our proof. If you are able to do this once, even if you don't get that last one, you won't beat yourself. You know, okay, but I gave it a shot. You know, and you're not going to get 0 there. Okay, let's see. A. What did we say? ECO equals to what? 90 degrees. What is that? Tan perpendicular to what? Radius. And then we said F1 equals to what? 90 degrees, right? That was given. Remember, the black one was given. And those two are corresponding to each other. So we say FB, therefore, is parallel to what? CG. We just write corresponding what? And not converse. Parallel lines, we don't write what? Converse. We are done with that. Check. Sweet. B is my favorite. B is my 5 marks for free. And so, but what do we do? Yes, talk to me. Who's raising their hand?
So,
Yeah.
so will I be wrong if I say F2 is equals to 90 and then the reason will be angles on a straight line?
You're not wrong.
And then F2 is equals to 90 and then C2 plus C3 is equals to 90, meaning angles in a semicircle.
Huh?
I'm saying C2 plus C3. C2 plus C3 is equals to 90.
Yeah.
And then the reason will be angles in a semicircle.
Which question are you answering?
Question A.
But already you are moving away from the lines. Which lines are you proving that are parallel? This and
FB and
but you're already saying this is 90. Can you see I'm out of the line?
oh, okay.
I'm proving this too. So already, do you see that you're out of it?
Yes, sir.
So stay in the parameter of, that's why you draw them first and see what's going on. 90 and I thought you were coming here and here.
Oh,
Co-interior. That's what I thought when I had F2. So I thought you were coming co-interior.
no.
But once you start drawing C2 and C3, you are writing everything in the diagram, which has nothing to do with those lines.
Okay, sir.
All right. So we stay in the confinement. Guys, triangle FCB, what do? We list. Okay, I'm going to do it here. We want to please get this one correct. FCB parallel to what? Triangle what? CDB. Look, they didn't say to prove whether they are similar. They know that they are similar. So don't try to take over, they are not similar. The examiner knows that these triangles are what? Similar. Let's list FCB. Look at it. Which let's stress it. C, and B. What angles? F2, C1, B2. Angle F2, angle C1, angle what? B2. Okay, let's go CDB, C, D, and B. Okay, look at it. C2, C3, D, and what? B3. Okay. What did we say? We said C2 plus C3, D2. Now, already I can tell you that all of these angles are equal. Now, let's go. What is F2? F2 is 90. C2, C3, 90. Okay, so we're good. Both of them are equal to what? 90 degrees. I only need one more. Come now. Let's go for C1. Go back to your grade level knowledge. Where's C1? Tangent and a chord. What is that equal to? Which chord? D2. So angle C1 is equal to angle what? D2. What is that? 10 chord. I don't need to prove. Third angle. Therefore, triangle what? FCB is similar to triangle what? CDB. What's your reason? Angle, angle, angle. But there's something that we need to write. That's C2 and C3. It wasn't given. I just wrote 90 because I was still explaining. But you need to tell us why it is what? 90. So, also tell the F2. So, for me to start, but I've done my rough work already, right? My groundwork has been done. And you see, you're not struggling. You are very direct. So I just need to state that F2 equals to what? 90 degrees. Angles on a straight what? Line. C2 plus C3 equals to what? 90. Angle in a half what? Circle. Then I have my 5 marks. Please list the angles. Life becomes a lot easier. Don't try to move around too many. You know, if you're moving around, you're going to suffer. You will suffer a lot. Are we okay? Good. And once you do that, you are creating time for the last one. All right. Give a reason why G1 is 90. I think we even mentioned that. Line drawn from what? Center. We're done. Line drawn from center. We're done. Lovely. Prove with reasons that CD squared. This is where I find myself now. These are the things that I love. Prove that CD squared. Again, I'll teach you 2 things. Prove that CD squared. Let's write it. CG what? DB. The first thing I'm going to do. CG squared is what? What is it again? CG and DB. Guys, let's find the source where it came from. Most of the time it works. Only few times. For me to get, is it CG or CD? CD. For me to have gotten CD squared, it means I have actually multiplied CD, and so let's try it. CD, but there's something we didn't do. I'm breaking my rule. I didn't write my ratios. Okay, can we quickly write that ratio? Please, every time I prove, we always write the ratio. What was that triangle again? Triangle FCB and CDB. FCB, similar to triangle what? C, is it CD or CB? CDB. All right. I'm thinking of CBD, Central Johannesburg or district, what. Okay, come quickly. What's our ratio? First 2 FC over CD equals to what? CB, last 2 over what? GB. That's just write that and leave it there. FB over CB. Okay, smile, smile, and the mustache. Smile, smile. It's the face of a person. Okay, you have your eyebrow, yeah, and your smiley face. Okay, so I have this. Let's first check. Is there CG here? No. Is there DB? Huh?
There's DB and it's CD.
Okay, hold on. There's what?
DB and it's CD.
So we're checking all of this first. See, there's what?
CD
Okay, there's CD.
is DB.
Where's DB? Oh, there's DB. What about CG?
Mm-mm.
No CG. But I have these two, right? Okay. Hold on. Can I go back to the diagram? Let's check something.
Right angle triangle.
Wait, are there lines that are equal? I just want to quickly check something.
The radius is CO and OD.
Okay, COOD, and that has nothing to do with what we have now, right? Okay, we're just checking. Sometimes we have that. All right, but let's go and deal with working backwards, and then we can combine. CD squared, I have multiplied CD and CD, right? Then I can distribute this one, CG, and I'm working backwards. Make sense? I'm working what? Back. So I know that if I cross multiply, I'll get that top. Okay, do I have three letters here? Yes. C, G, and D. How many letters do I have here? Oh, no, three. It's C, D, and B. So I first broke it down. Check if I have three letters. Three letters means a triangle exists. So let's go see. Does triangle CGD exist? Already we know CDB exists. But the CGD, does it exist? Yes, it does. All right. C, G, and D. Right? Okay, let me write it here so that we don't go too far. So we are looking at what? C. If we can prove that those two are what? Similar, then we are done. C, G, D, and what? C, D, B. Give me the, now in this case, I'm the one trying to prove. How many marks is this? 5. Okay, it's worth it. Guys,
P3 is equal to number.
all right, let's just list. This one, if there's no order, right? So CGD, what do we have? C3, G2, and the whole of angle what? D. We good? What about CBD? The whole of angle C? No. C or C2 plus C3, B3, and D2. Okay. What is C3? We don't know. We don't know C3, right? Then, what is G2? 90.
Maybe no C2 and plus C3 is also.
We also know this as 90. So these ones are equal. I'm matching now. Okay. What is B3? We're not sure. We're not sure. We're not sure. But hold on. Hold on. Look at what we proved earlier on. Oh, we proved that. Oh, wait. Look at what we proved. B2 is equal to B3. I wanted to tell you something earlier, but I forgot. The ones that I've proven that they're equal. Let's write it there. But do you know that D2 is also equal to what? X. Am I right? Tan code.
Mm.
Yeah. Tan code, we did. Come on, people. Are you now forgetting our tan code? No, sorry.
Mm.
It was what?
C1.
C1. Okay, let's do this. Sorry. I was kind of excited. Okay, hold on. That is Y. Let's call that Y. And let's call that Y. Just to, it's easy to quickly see. Okay, let's go back. Do we know C3 now? Nope. Oh, do we? Yes. Yes. C3 is actually equal to Y. An isosceles triangle. So C3 is y. We will do all the write-up later. What is D2? Two angles have now matched. Two angles. Guys, let's quickly go back and do it all over again, because I want us to see what's going on. Some of you are like, okay, whatever they are doing, I just write. No. First, we did our similarity, right? Every time you prove a similarity, you write out the ratio. So the first thing was, I came here and we checked. Do you know why I went to check if there was anything equal? I wanted to check if CB was equal to that. Then I would have said CD squared.
Yeah.
But that didn't work. And I came here to say, okay, where would this have come from? This would have come from the fact that I'm multiplying CD and CD. And then this would have, if it doesn't work sometimes, just flip this one here and flip that one back and check. You're looking for what? 3 letters. All right. So, but luckily, C, G, D. And then what? C, D, D. Let me do something so that we stay on this page. I want to do something quickly. So any letter you find, any angle that you find, just quickly use variables. K, Y, W. There are 26 of them that you can use. Can't say you don't know. 26. In fact, more than, if you are done with those 26, bring in theta, alpha, beta, gamma, omega, whatever it is. So you have about 30 variables, J, K, P, L. If you are done, write your name there, my name and that one. So, okay, just to make sure that you enjoy what we're doing, okay? And the quicker you write them, when you write them, you quickly see the angles. Okay, we said B2 is equal to B3 from the first question. I wanted to say that I thought, maybe it will work. But now it caught up with me. XX. Tan chord, Y, and Y. Remember, radius. I promise if you go check that picture that I showed you. Please, everybody look at the picture that's on your group. I want to show you something. If you can switch, those of you at home, if you can quickly move, don't go to what, don't read messages. Leave all those messages that you're supposed to read. Just go there. Look at R. Radius. What did I say there? Number 7. Angle at center. What is number 8? Isosceles. Once I see number 8, once I see number 8, angle at the center is 2 times angle at the circumference, and what? Isosceles. Isosceles means what? 2 angles are equal. 2 sides equal, 2 angles. So that's why this one is that. Okay, so okay, all right. So CGD, what did we label again? C3, G2, and what? Which angle? The whole of D, right? And then CDB, what did we say? C2 plus C3, D2, and what? V3. We said C3 now. We know C3 is what? Y. What else? D2 is equal to what? Y. What is G2? 90. This one is also what? And all I need is to prove 2. So what will my write-up be? Let's work. Angle C3 is equal to angle what? D2. What's the reason? Angles opposite equal what? Sides. So I'm done with this one. What's next? G2 is equal to what? Angle C. 90 degrees. That has been proven, right? Therefore, can I make my conclusion? What's the third letter? Angle D is equal to what? Angle B3. What do I write? Third angle. Therefore, now I have arranged my own. What would I say? Triangle what? CGD is similar to triangle what? DC. You see, I'm following my order. What's your reason? Angle, angle, angle. Eyebrow, eyebrow, smile, eyebrow, eyebrow, and what? Smile. Let's write it. What we have? CG over what? DC equals to what? GD over CB equals to what? CD over what? DB. I'm looking for CD. Do you notice I'm done with it? CD, CD, so definitely CG and DB. But how do I put this down now? Guys, I'm going to clean this part. That's why it's 5 marks. Actually, it should be 6. Normally, they give 6. Now, I'll come here and say what? CG over CD. I'm only going to write the one I need, right? And what's my reason? Similar what? Triangle. I'm writing that because the triangles are similar. Can I cross multiply? CD squared equals to what? CG multiplied by what? DB. 5 marks.
It's long.
Huh?
It's long.
Yeah, it's kind of long. That's why I said normally they give 6 marks. But it's because we have to find the triangle first. All right. So work backwards. You're safer than somebody who's doing trial and error. I promise you. I used to do trial and error before, and I used to suffer. But then I thought, no, life cannot continue like this. Life can't continue like this. What? There must be a way out. Okay, and then
Long division method.
until we came with the pro one. Okay. All right, guys. You can watch this again. You know, wake up in the morning, first thing after praying, you watch this. What's the last question? Oh no. Prove that what? DB equals to what? CG. Oh Lord. Plus what? FB. Okay, come, let's try. Let's try. Prove that what? Prove that what again? Let's see. DB, CG, FB. DB. What? Okay, but I cannot do anything like this. It's too vague. Let's bring in. Okay, guys. Let's try. We're going to try quickly. But bring out the 2 ratios that we have. Huh?
Still a 90 if you give these 5 marks.
Okay, but let's try. What are the ratios that we brought? Let's bring them out. Quickly write down the ratios for me. I need my keyboard, another keyboard here. Just quickly write those 2 ratios, please. Okay. Got it 2?
Yeah.
Somebody got 1, the other person got 1, right? Okay. Please make sure it's correct. Don't give me a wrong thing. Give me the ratio. FC over CD, CB, EB, DB, over C, D. Okay. CG
over DC,
over DC,
then GD, CB,
CB,
CD,
CD. Okay. What are we proving? That DB is equal to what? CG plus FB. First thing is I'm going to go to my diagram and trace. See what's there. Where is DB? Oh, beautiful. Oh, I think I found something. Diameter. Just by looking at that, I think I got something. I don't know. Hey, CG. You just ruined it for me now. And FB. What the heck?
That's not even trying.
Okay, but hold on. What did you notice here? That's a diameter. Immediately we mentioned that word, I remember that this is giving me what? A right angle triangle. Does that make sense?
Yeah.
Look, I'm just going to try something that came to my head quickly. So I know that that is connected to right angle what? Triangle. And we have another one on top, right? But let's see. If I were to pull up Pythagoras, what would happen? That would be my hypotenuse, right? Okay, we're just doing a rough work first. DB squared equals to what? BC squared plus what? Hold on. Don't I have CD squared? Of course, CD squared. What is our CD squared? Let's bring that in quickly. CG and what? DB. Okay, hold on. BC squared, CG and what? DB. Guys, I'm done. I've seen my answer. So I have a problem with BC squared. Look at that ratio. Okay. Oh, this one makes me look like a pro. It doesn't really work. So what would that be? We don't even know whether we're going to get it yet. But if I cross multiply, CB squared will be equal to what? FB times DB plus what? CG. What is common? Let's divide everything by DB. What do we have? DB, FB. Again, what helps me is I went back there. The theory is going to ring in your head. Immediately I heard the word diameter. I connected it to what? 90 degrees. I connected it straight to Pythagoras. It's either Pythagoras, proportionality, or your ratios. Guys, I hope this makes sense. Imagine getting this for the first, like your first trial in the exam. Yeah, I killed it. All right. But guys, I think, look, spend some time tomorrow. Do a whole lot of some of these things, please. I'm not saying it's going to be straightforward. It's not going to be straightforward. But some hints will just, we're not going to get zero. Some hints there, here and there. But again, what are the things that made it a bit easy? Ratios. Let the ratio be, always go back first to check. Always go back first to check. Oh, then one thing that I wanted to tell you is look for lines that are equal and put them down. All right. So an examiner would actually be referred. In fact, if they wanted to make this, I could actually create another question. I want to use DB. Check. If I wanted to create, like I want to be wicked now, I won't use DB. I'll use 2OD. Which means by the time I bring it here, it will be 4OD squared. Because it's 2OB all squared. 4OD squared. Now, it creates a problem. But if you think and you quickly notice, do you notice I asked which lines are equal earlier on? Because I want to quickly see what's going on. I know that what? CO is equal to what? OD, which is equal to what? OB. They are all what? Yeah. Now to take, you see, to completely remove you from the whole thing, you know. So please, and then an examiner says CG, and you are thinking CO plus OG. Now you are fine. How am I going to get this OG? But here is my final word for the day. We're closing, guys. I want to beg you on this question. Don't mess this up. Here, maybe not, right? If you are lucky, you know how to work backward from there, and it's simple enough. Don't cry over this one. The only reason you would cry over this is if you have messed up here. Then you are looking at the whole marks and say, oh my God, I'm losing 25 marks. But if you are meticulous in that, you pat yourself at the back there, but okay, all right, no problem. I hope it makes sense. Please, very, very important. All right, please, let's use the group. I've taken you through analytical, sorry, what? Euclidean now and what? And trigonometry. Last week we did analytical, I think. All right. And then please don't commonize statistics like that you learn it on Monday morning. Please, no. Doesn't work like that.
Just getting like 5 minutes.
I know we did in like 10, 15 minutes, but please.
In between,
That is giving you a challenge. Look for questions wherever you are challenged. Please don't suffer alone. We are a community. Yeah, let's suffer together. And while we are suffering, we are building. Let's build some muscles together. Please share all the questions that you come across and let's work together. Have a lovely night, everybody. Go and rest. Yes.